Escaped Sapiens.
Every time we shoot rockets up into space, nose cones are ejected, fairings are dropped, fuel tanks are left up in orbit, and even entire stages. Astronauts drop tools, weapons tests on satellites spew shrapnel into orbit, and dead satellites drift on silently for years. There's a lot of junk up in space, and with commercial players entering the game, there's going to be a lot more. Launch windows already need to be timed to avoid flying debris, and the International Space Station needs to shift its orbit to dodge hurtling chunks of metal that would otherwise punch holes through its protective shielding. On this episode of the podcast, I speak with Jonathan McDowell, who is an astrophysicist at the Harvard Smithsonian Center for Astrophysics, who for decades has been keeping a list of all the objects that humans have blasted up into space and a catalogue of all known geosynchronous satellites and their positions. We discuss the severity of the problem, some of the crazy ways that junk has managed to find its way up into orbit, the impact of collisions and deorbits, and the possible solutions to the problem. This conversation was pretty eye-opening for me. I hope you enjoy.
So there are two branches to my life, right? One is the cosmology and the other is the satellites. And they came from different places really, but they've sort of started to merge now. The space report was, when I was like 12, I started making lists of rockets and satellites, as many kids do. I just never gave up. And then when I moved to Harvard, to the Smithsonian Observatory, that was a place which in the 50s had been the information point for America for when is Sputnik going over your town. And Fred Whipple and people like that had pioneered, a lot of space science there. But those people had all retired, and yet the public were still phoning SAO to go, what's this thing I saw in the sky, right? And what's this thing I heard about in space? And pretty quickly, the public affairs people realized that I was someone who could actually answer these questions. And so they kept phoning me out, going, oh, we got this, was that. And so in self-defense, I started writing a weekly briefing for them on these are the space things that happened this week that you might get questions on. And someone said, oh, that's actually quite useful. Maybe you should put it on Usenet. And there's maybe 5 other people in the world who want to read this, but no, it turns out people are interested. So that's sort of how it began.
How big is the reader base?
Hard to tell, because mostly now it's sort of just on the web page, and I don't have it with a web counter. It's when it was mainly email, it was several thousand.
Okay, and so presumably it's much larger now than that.
I think so. Yeah. I mean, I have 85,000 Twitter followers, so that gives you scale, and which is insane. But apparently, there are people who like geeky technical information. Who knew? And I think that's come because I've been. I do try now that I have a wider readership to do a little more explanation of things and a little more, simplification, but I haven't compromised too much. And I still see my main target audience as engineers and scientists who are frustrated that Aviation Week and the other, sort of techie publications just aren't geeky enough. And don't have enough numbers in them, and so that's sort of been my brand. Is
you play to that niche?
I play to that niche, and anyone who finds that interesting is welcome to tag along.
In terms of actually getting your hands on the data, though, can you get access to all launches, or are there some launches that, for security reasons, spy satellites, military satellites, are there some things you simply can't get your hands on?
Up to a point. I mean, U.S. intelligence satellite launches and some allied intelligence satellite launches, that the launch has happened, but the Space Force doesn't release the orbital parameters. Now, there is a United Nations convention that the U.S. is a signatory to that says you've got to say what the orbits of your satellites are. But that implementation of that is fairly pathetic, to be honest, because you get that information like 2 years later, and it's not a complete set of elements. So it's better than nothing. But so instead, for those satellites, we rely on hobbyists.
Okay.
and amateur astronomers, essentially. And it turns out that most of these secret satellites are as bright as the brightest stars in the sky, and with binoculars and a stopwatch, you can and like 3 people in different places, you can easily derive their orbits. And so that's one of the really fun things, is that really, orbital determination, right, goes back to Gauss in 1801, finding the orbit of Ceres, and it's not high tech. And if you have a bright thing in the sky, attempting to keep it secret is an exercise in futility.
Which makes me wonder why they do keep it secret. Surely it would be safer if all the orbits were known in terms of collisions and this sort of
Absolutely.
thing.
And I think that's coming. I think they're finally being dragged around to the view that that's going to have to happen. I think partly they're just in denial, because they use these big expensive radars to determine the orbits. They can't quite get their head around the fact that you don't need that for the big satellites. I mean, there are some in geostationary orbit that are, a lot fainter and a lot more challenging. And so it wasn't really till the early 2000s the hobbyists started getting all of those. But you need a little bit of a telescope. You need maybe a telescope with a CCD, but everyone has those now. And so, yeah, it's really one of these things. I mean, this rampant overclassification in the national security sphere. And it came out, and it's a tradition. They started making the orbit secret in 1962, and they were worried that the Soviets would target their satellites and things like that. And it never really was terribly successful, but they just can't seem to get past it. So hopefully attitudes are changing, and they're realizing that it's sort of pointless and makes them a laughing stock.
Have you taken part in some of these hobbyist, with a stopwatch and calculating orbits yourself? Have you taken part in any of that as a hobbyist?
I've done it once or twice, but honestly, I just don't have the time to. Yeah. And Boston, where I live, is not the best observing site in terms of the weather. So I just sit here like the spider in my web and look at all the data flow and let other people do that. And really, what I have to offer is that I've been sort of making these lists of rockets for 40, 50 years now, and so I have a lot of knowledge about all the satellites that have ever gone up, so I can spot patterns, and I can know when I see something happen, I can know what it means a little easier. And so that's been where I've put my effort, and just pulling it together, adding some math, doing some orbital calculations, and then trying to explain what it means for the public.
I read back over some of your earlier entries just to compare with your very last one. And there's been quite a change. I mean, recently, I guess China's come into the game, and there've been moon landing, Mars landing, their own space station, shooting down satellites, a lot of activity. And then on the commercial side, there's SpaceX, and Bezos and Branson just went up, a week or so ago, whenever it was. It seems like we're in a new sort of space race. Do you have any idea, in your mind, why is this happening now? Has technology gotten to a point where this is able to happen, or are there new financial incentives? What's your view on what's going on?
I think there are two things, and let's say that there have been several changes in. I don't want to call it a space race. I think that's a very Cold War characterization, but I think it's a dramatic increase in activity in the space sector. If you like, a new maturity of the space industrial sector across the world. And so there have been a number of related but somewhat independent developments. The first of which was when the CubeSats were invented in 2003, but they only really were good for student webcams of the world until about 2013, when the miniaturization caught up enough for these CubeSats to do a useful job. And so now you have all of these startups that can launch CubeSats for a relatively, let me put it another way, that the barrier to entry to space has come down. In the 1970s, you had to be a superpower, right? In the 1990s, with there's a company called Surrey Satellite in England that leveraged one of its amateur radio satellites into a Earth imaging bus that it could sell to developing countries. And so a developing country's budget was enough at that point to get you a starter satellite. And then with the CubeSat revolution, and really starting in the mid 2000s to 2010s, it became feasible on a startup's budget.
So what sort of budget are we talking about just for the CubeSats? These are small. How big are they?
They're the typical ones now are about 0.3 meter, 30 centimeters long, a foot long hot dog. I think about it. They're 10 to 20 centimeters wide. So they're really small things. They're about 10 kilograms. And but they can actually do some useful stuff, especially if you have 100 of them.
Yeah.
And so, people talked about this for the longest time, but it's finally come true. And there are a number of large commercial constellations now. Planet, which has several hundred satellites imaging the Earth every day. And that's partly for resource use management, but it's also really useful for news agencies. So if you saw the stories recently about the new Chinese missile fields that were discovered, that came out of imagery from Planet. And that was, in an earlier era, the intelligence community might have known about this, but the public wouldn't have done. But with Planet, journalists can get access to this data and discover things. And so that's really changed things. Then the other thing that happened was in the 90s, we had the dot-com boom. And we made a whole bunch of new billionaires who didn't come out of the financial sector, who always, when they get their billions, want to do boring things like make more money, right? They came out of the tech sector. And so you had all these billionaires who had wanted to be space cadets since they were little. And so they set up their own space programs. And so I really think that's why we're seeing it now. It's the difference in the kids who became billionaires in the 90s compared to who became billionaires in the 80s. Very different interests and motivations. And so thanks to that, and Elon Musk with PayPal, Jeff Bezos with Amazon, right, are the classic examples, but there are many more lesser well-known examples. And so I think that that drove the massive private individual investment in space. And so that came together with this lower barrier to entry. And to make the commercial side of space really take off. The other thing that I think may have played in is the ubiquity of GPS. And so, GPS has been around since the 70s, operational since the late 80s, early 90s. But, it's the end user widgets that use GPS that have really become pervasive in our society just in the past, 10, 20 years. And so as part of that, satellites now carry GPS that make them more capable, that is easier to track and do things. So there's whole new applications. For example, there's another constellation that does weather forecasting, not by the conventional, let's look in the infrared at the cloud layers or whatever. They watch a GPS satellite setting over the horizon. And the absorption of the radio signal from the GPS satellite on its way to this little weather satellite can is affected by the temperature and pressure of the atmosphere.
I've never heard of that before. And
so this is called GNSS radio occultation. Global Navigation Satellite System Radio Occultation, GNSSRO. And so it's a way of using the atmospheric distortion of a radio signal to back out the temperature and pressure with height profile of the atmosphere.
And how does that compare to traditional methods? Is it?
I'm not enough of an expert to know that. It's clearly useful enough that it seems to be something that's a whole sector now that the US has systems, China has systems. That it's happening quite a lot. So that's just one of these unexpected spin-offs, right? So I think we're seeing new applications of space. The Internet of Things is now a lot of data, low bandwidth data that needs to be transmitted home, right, into the cloud. So in this case, above the clouds often, in addition to the traditional telecommunications and imaging applications, and so for a long time, space was 1/3 civilian, 1/3 military, and 1/3 commercial. And just in the past 5-10 years, the commercial stuff has blown everything else out of the water and is now completely dominant.
I guess the reason, one of the things I'm curious about is, originally, if you go back, 60, 50 years, there was the race to the moon, right? So there's this big goal that sort of pushed, progress in space forwards. And then we went into a period where there was the ISS and space shuttle. And there wasn't sort of this big directed push towards something. And more recently, I suppose, with Elon Musk, there's this push to go to Mars. But I suppose, it sounds like what you're saying is that these big goal-driven missions are not necessarily the most important thing these days. It's more that we've entered a new phase where there are economic drivers that are sort of taking over.
That's right. Well, I would say this: people still talk in terms of a space program. We don't talk in terms of a sea program or an air program, right? It's the atmosphere and the seas are just one of the places that humanity does its stuff. And Earth orbit, at least, is now in that category. It's just one of the places where things happen that humanity does. And yes, there are these big goal-driven programs, but there are also just, there's just stuff that goes on. And I think people, the public hasn't made that mental transition yet, but the frontier is now really, for a long time, it's been, beyond Earth orbit. And now it's actually, we're starting to normalize the inner solar system. We're starting to see infrastructure for, the space out to Mars, dedicated communication satellites in orbit around Mars, that kind of thing. We're going to probably have a GPS for the inner solar system at some point, and to a service industry for all the other things that are going to happen. We're seeing international, it's not just the superpowers anymore going to Mars. We have India and European countries and Japan and so on, and it's not now the frontier is moving out to the asteroid belt. And similarly for human spaceflight, which is the thing that gets the most attention and costs the most, the space station is all very fine, and we've learned a lot from it. But now the push is, as you say, to go to the moon and Mars with humans, again in the case of the moon, and so we've turned over the delivery of astronauts to the ISS to a trucking company. Right? It doesn't need to be NASA anymore, because NASA's job is to do the frontier. And low Earth orbit is no longer the frontier. And I think it's as simple as that. So we really have seen a transition where it's not a major government effort to do things in low Earth orbit now. It is still kind of a push to get people to the moon and certainly to Mars, but for stuff in Earth orbit, you just have a startup and you launch something, and it's not that much different from starting a business on Earth. So that's, I think, the change.
So on the commercial side, then, with regards to these most recent launches, do you consider Jeff Bezos and Branson astronauts? What's your view of these most
I
recent?
do. There's two questions, right? Did they go into space, and do you use the word astronaut to describe them? And so, as I'm sure you know, so back in the 90s, when I was really starting my big list of rockets, I had to decide, and I was one of the first people to do a big list of suborbital rockets as well as orbital ones. I had to decide what would count and what wouldn't. Mm-hmm. And so I started thinking about where does space begin, and I pretty quickly figured out that it was somewhere around 80 kilometers. And I finally formalized that in the paper I wrote in 2018 about the Kármán line and why it's really at 80 kilometers. Mm-hmm. And so that's been, my argument for a long time now, that anything that goes above 80 is in space, however briefly. And then the astronaut terminology is a little trickier because words have multiple senses and they evolve, so you can imagine. I mean, if you think about aviation in the early days of aviation, right? There were some words that were used to describe the early pilots. Pilot is one of them. Airman, aviator, right? Flyer, right? And those magnificent flyers in their flying machines, kind of thing, right? Where that was largely meant pilot in those days, but now frequent flyer doesn't imply that you had the controls of the 787, right?
Unless something goes really wrong.
Yeah, right. And so I think we're at a point now where we've been using a bunch of words, space traveler, astronaut, space crew, that are now going to start becoming better defined. It's been okay to be vague because everyone's been basically everything. And that's gone up. Now we're starting to see these different roles, in particular crew and passengers. And so the terminology is going to shake out. My prediction is that it will shake out in the way that astronaut means anyone who travels in space, and we'll have another word for the professionals who fly the spaceships, if there are any, like space crew, or I've been advocating spacer because that's sort of like the 1950s science fiction kind of name, but by analogy with sailor, right? And the reason I think astronaut is going to be the general term that applies to the tourists as well is that the tourists have an interest in that being the result, and the tourists are uniformly super rich and powerful. And so that you have all of these incredibly influential people who now have a vested interest in making the word go that way, and so that's why, and I'm comfortable with it. I think it's a reasonable way for the word to go as well, seriously. So I am not that interested, for my purposes, in making a distinction between who's the truck driver and who's the passenger. I'm just making a list of people who have been to this strange place.
So in terms of your own writing, actually keeping up to date with your space report, is it now getting to a point that it's difficult? Or, I mean, just because there's so much going on at the moment, or are you still able to keep on top of all this?
I've got it down to kind of a fine art. And everything, people make fun of my website for its old-fashioned look, but it's all optimized so that I can make my updates in the absolute minimum amount of time necessary. And so it's all text files in Emacs. And so so I'm keeping up for now, but you're right that the thing that's really hard is these launches that deploy 100 different satellites for 50 different organizations. And so every time, and there's always all these new startups, right? And so I have to not only it's not just cut and paste because each one is different.
Mm-hmm.
And to add a new one, I'm like, okay, so this has a new owner. Mm-hmm. So I have to add the owner to the owner's database and find out, research information about that. And then I have to, if it's a new country that owner is from, I have to add that to the countries list. And so there's all of this, background metadata mm-hmm. that adding a single satellite can, be labor intensive. Whereas if it's just 100 more satellites from this company that's launched mm-hmm. hundreds before, that's very easy and very little work. So it's actually the increased diversity of the players that is the biggest challenge for me, rather than the increased number overall.
You're going to have to automate this. You learn how to do data scraping or something like this at some point. It sounds like.
Yes and no. I mean, yes, but then the whole point of the whole fun of it for me is doing this research and learning about new things I wouldn't have learned about otherwise. And so but there is going to have to be a point where I just say, give up. Jonathan's History of Spaceflight, 1957 to 2025, and someone else. I mean, at some point, someone else is going to have to take over anyway. So. That's if anyone listening is really obsessive and dynamics and a librarian at heart, then let me know, because I can't do this forever, and so there is going to have to be a point at which I draw a line and go, okay, I'm retiring. I'm going to just improve the list of space launches from 1957 to end date and make that really good for the history. And what I've told other people is, the reason I do this is actually not for my current readership. The reason I do this is for the historians 1,000 years from now. Mm-hmm. Because I got really frustrated at the way that information about what actually happened in space was disappearing. Mm-hmm. And the professional historians are more interested in the sort of office politics of how the thing gets funded and so on. Mm-hmm. And so a lot of official histories of space projects are like 90% pre-launch and 10%, and then they launched the thing and it worked fine.
Wait, so is there data on your report that it has disappeared otherwise, or?
I have stuff in my library here that is the only copy left in the world, because the company went out of business, and if I hadn't dumpster dived them the previous year, or the government agency just threw its records away, or if I hadn't harassed that project manager to telling me this number, it would never have gotten written down anywhere permanent. And because when a project, there's all this paperwork you have to do, right, to get your satellite launched. Yeah. And once you launch, you often don't have a lot of time to write things down because you're so busy. And then the mission ends, especially if it ends prematurely, and you get taken on to the next project. And in the early days, like if you look at the Ranger probes to the moon in the early 60s, there are these fabulous post-mission reports, hundreds of pages long, that give every geeky detail of what happened, right? And at a certain point, they stopped funding those, and you never get them now. These like, I'm writing this a year after the mission ended, and this is the timeline of what actually happened during the mission, as opposed to what was planned to happen. And so I'm the first order, the only person who bothers to write this down. And so if someone in the future wants to go back and go, all right, where did this probe actually go? When did it reach Mars? When did it touch down? What went wrong? That I'm trying to preserve that information in a uniform way, right? Mm-hmm. So that you can do that for any mission. And it's just, especially now in this day of pure electronic records, right? Mm-hmm. A lot of the technical data is internal and electronic, and probably won't get backed up properly and probably won't exist 10 years from now.
And I suppose also, even if it does exist, then finding that data, I guess part of the value of what you're doing is that it's all together in one place in some consistent form. So in terms of tracking objects then, what percentage, since we should get onto topic at some point, what percentage is space junk and what percentage is, active and useful equipment?
Right. So the first thing is you have to set a threshold, right? Because in low orbit, the radars can detect things down to about 10 centimeters in size. And we know that there are probably about 1 billion objects in Earth orbit above a millimeter in size, right? But we can't track them. And that is all just debris, right? And so let's just talk about the cataloged object population of 10 centimeters and up. Mm-hmm. And it's at higher altitudes where the radars can't reach and you're reliant on telescopes, it's incomplete. Mm-hmm. But it still gives you an idea. So we're tracking about 23,000 objects in Earth orbit every day. And about 4,500 of those are active working satellites. Okay. And then the rest goes to there's about 2,000 dead satellites still in orbit. Okay. There's about 2,000 rocket stages left over from launching them. There's about another 2,000, what I call litter.
Like spanners and things that astronauts drop?
And mostly sort of like fairings, nose cones and connectors and deployment devices and things like that. But lens caps as well, that sort of thing. And then there's about 12,000 pieces of, I want to say, accidental debris. It's not all accidental because some of it's from military weapons tests, but explosive or fallen off debris. And so a lot of that is from, if you launch a rocket and you don't use up all its fuel, you have leftover fuel and oxidizer in the tanks. And this thing sits orbiting the Earth for several years, and then the sort of O-rings between the tanks erode, and suddenly where you had one object that you were tracking, it comes over the next time and your radar see 300 objects, and a lot of kinetic energy.
And you have to give a number to each one of those officially?
Oh, absolutely. Yeah. And so because they're going to come over the next, and here's the problem, right? You've got 100 objects that come over your radar, right? Mm-hmm. And then 90 minutes later, you have the 100 objects come over again, and your task is object number 34 from the second pass the same object as object number 48 from the first pass?
Mm-hmm. Is it? I guess you have to work out which object exploded as well. If objects are fairly close to each other, that could be a problem.
That's true. It's mostly easier than you might expect. There are some conserved quantities in the orbital elements that make that sleuthing actually fairly tractable most of the time. As long as you don't. Sometimes you find an object that separated from its parent, 2 years ago. Mm-hmm. And that's a little harder because especially if there's a constellation of objects in the same plane, and so with similar conserved quantity parameters, but it's just you don't know which one it drifted off. Mm-hmm. So it can be tricky, but mostly it's tractable. And so you have all of this stuff to keep track of. There's the exploded rocket stages. Batteries have a tendency to explode. Anything that has stored energy, right? And then there's accidental collisions, which are not a big deal yet, although there was one big one in 2009. And then there's anti-satellite weapons tests, which are just, they shouldn't happen, but they do. It's just inexcusable, I think.
How often do those happen? How many of those have we had?
Well, over the age of the space age, we've probably had about 20 or 30. The Soviets did some in the 1960s. The first one was in 1968. And then the US did a couple in the 80s, and then there've been the Chinese and Indian ones in the past several years. And some of them were done at low altitude, where all of the debris re-entered within a few years.
Mm-hmm.
And some of them, like the Chinese test, happened right in the middle of sun-synchronous orbit at a high altitude, and that debris, there were, I think, 3,000 objects cataloged, and about over half of them are still in orbit now, 10 years later.
When was that rocket test that the Chinese did?
That was 2007. 2007. There was, I mean, debris can stay up for a long time if it's in high orbit. So roughly speaking, right, I've started encouraging people to, we talk about LEO, low Earth orbit is a term that people may have heard. And low Earth orbit is between about 200 kilometers and 2,000 kilometers above the Earth. But I've started talking about lower LEO and upper LEO because at about 600 kilometers, there's sort of a dividing line where below that, things are going to re-enter in a year to 20 years due to the thin outer atmosphere. And above that, things are going to stay up for decades to centuries.
So why did they do this test higher up? Was that because they wanted to see, you know, the effectiveness of their weaponry at higher altitudes?
Frankly, it was because they were idiots. In particular, it was because the test was done by the ballistic missile people, and they didn't talk to the space people.
I see. So what they literally shoot a rocket up. Is that the only type of weapon, or
no? There are several types. This particular type of the Chinese test was it was just a missile that they fired up, and that it managed to be in the same place at the same time as this satellite, and the satellite's own, you know, relative. The satellite's going at 18,000 miles an hour, right? And the missile's going slower, so the relative velocity is large, and so if you physically contact, then that's a lot of momentum transfer.
I see.
That makes a hypersonic shockwave go through the object and reduce it to shrapnel. And there are other approaches. So the early Soviet tests were what were called co-orbital. The satellite went up into an orbit near the target satellite, and released shotgun pellets in a high explosive warhead because they couldn't target it accurately enough to actually hit. But if they released like 2,000 pieces of shrapnel,
perfect.
Yeah, really great. Thanks. Has there been another kind? Those have been the two main kinds used in practice. Yeah, I think that the Indian test and the more recent. There was another type that was deployed by the US in the 60s that never actually got tested live. It got tested against fake targets with dummy warheads. But that was, instead of actually hitting the satellite, just launch a missile near the satellite and explode a nuke in front of it.
Wait, that's being done?
Not actually with the nuke, but they had Thor missiles with live nukes sitting on Johnston Island in the Pacific, ready to do this if they ever needed to. And then they would take the live nuke off, put a dummy warhead on, and do a test launch to check that they could get close enough to the target. They did, and they knew that the effects it would have, because in 1962 they did a test where they not against a satellite. It wasn't meant to be against a satellite, but they did a nuclear test at 500 kilometers altitude. And with one of these rockets, and it created an artificial Van Allen belt that lasted for about 5 to 10 years.
Okay, so this is like ionized particles that are
relativistic ionized particles surrounding the Earth in a radiation belt, and there were only a couple dozen working satellites at the time in 1962. And over the next 6 months, about half of them died because their solar panels were irradiated by all this crap, and so it was not a good experience. But the early 1960s was a time, right, when people would go, I wonder what would happen if we blew up a nuke in outer space, and the authorities would go, huh. Cool, let's try it and see.
The golden age.
Yeah, right, right. Yeah, none of this sort of, review or
Hmm.
environmental impact assessment. And so, you name it. It's been there were plans to do a nuke on the moon, but they never actually got around to that. Um, so yeah, there were several like nukes in space, so that's another form of debris. Um, uh, Parenthetically, another form of debris that we have is that the Soviet Navy loves nuclear reactors, or did, I should say, Russian Navy now. And they had this spy satellite that would use radar to track the US Navy.
Mm-hmm.
And the radar needed a lot of electricity to run it. And so they put they put actual nuclear reactors. We're not talking these wimpy Voyager style radioisotope generators that just run thermocouples off decaying plutonium. We're talking about U-235 critical fission reactors on a satellite as your electricity supply. And so, unfortunately, one of these re-entered over northern Canada in 1978 and strew radioactive debris over large areas of Saskatchewan.
Yeah.
And, so that wasn't great. But they said mostly in operation, they boosted the reactors up to 1,000-kilometer orbit so that they would stay up there.
But that mechanism broke, I'm guessing.
Hmm?
That mechanism broke
on the one. Yeah, but even the ones that succeeded, right? Now you've got these dead nuclear reactors orbiting the Earth, and some of them had leaks, and so there's this sodium potassium liquid metal coolant that they use that leaks out. Probably radioactive, I'm guessing, because it's been next to the nuclear reactor, and this liquid forms perfect little spheres, as in space. It freezes into little spheres, and so you've got this whole belt of tiny little sodium potassium reactor coolant spheres around the Earth. That's a significant contribution to the debris population at that altitude. And so all kinds of stuff. There was also the Project Westford. I don't know if you've heard of that one.
Is that the one where they shot up all the little pieces of metal?
Yeah, copper needles, several 100 million copper needles smushed into like a cylinder about this big, kept together with paraffin or something that sublimes once on orbit to dispense the needles. And so you got those up there that most of them are re-entered, but some of them are still up there.
What was that? That was to bounce signals off.
Yeah, passive. This is before they had active communication satellites. I thought maybe the way to do it is just have this passive reflector that had, dipoles of this particular length that would then reflect radio waves at that particular frequency. And so you could use that to bounce radio signals down to somewhere else.
But that's mainly cleared up by now, you said.
Mainly cleared up, but there's still a few million of these things in orbit, probably. Too small to track individually.
The spy satellites with the radioactive sources, I'm guessing, so you said they needed a lot of power to run. I'm guessing the reason why you can't run them off solar panels is they're low, and so they cause drag or something. Is that the reason?
No, it's that the Soviet 1970 solar panel technology was just not good enough.
I see. But they could have done that with solar panels, potentially.
If they'd had good enough ones, yes. And nowadays there are radar satellites that use solar panels.
Mm-hmm. Have there been cases of anyone intentionally shooting down someone else's satellite?
No. There's been no aggressive move like that in space yet. So always the tests have been against one's own satellite. Well, all right, slight exception. The U.S. Air Force shot a U.S. Navy satellite that was returning excellent astronomy data, and so obviously it was approved at some high level, but the urban legend goes that the astronomers who are using the solar physics data coming from the satellite had not been informed and were surprised when their data stopped flowing.
So with this this re-entry of the Soviet spy satellite over Canada, over Saskatchewan, Does Canada sue
Yes. So
Russia?
there is something called the Liability Convention that says if I fall on your head from space, I'm liable. And they didn't actually use that. I think it was sort of settled out of court, basically.
Mm-hmm.
But in the end, the Soviet Union paid about $3 million for the cleanup effort.
Only.
Yeah. I think Canada asked for, well, I mean, this is $1978, right?
Mm-hmm.
But I think that Canada asked for 10 and they eventually got 3 or something like that.
Mm-hmm.
So it was settled to the partial satisfaction of the parties involved, but not,
Except for those living in Saskatchewan, I guess.
Right. I mean, it was way out. I mean, it was a fairly low population area, but not zero, of course. First Nations people live there. So a lot of, and there was no actual physical damage. There's no actual damage to, say, property that I know of, but they did, it was very expensive because you found like beryllium control rods from the nuclear reactor melting holes in the ice, right? And you've got these pictures of people in hazmat suits with tongs, like, recovering these bits and going around with Geiger counters, picking up the little bits of radioactive material that they found everywhere. So it was fortunate that it was such a low population area and not, over a city or something like that.
So do we have mostly what you've been mentioning is sort of low Earth orbit and orbiting around the Earth. Is there also junk in our Lagrange points around the Earth? Are those sort of shockers as well?
So the thing to understand about the Lagrange points is that so the Lagrange points, right, for people who don't know, are these gravitational balance points, for example, between the Earth and the Sun. And so the popular ones are called L1. There are 5 of them, L1 through L5. And the ones we mostly use are L1, which is the point where the Earth's gravity balances the Sun about 1 million miles towards noon. And then the L2 is 1 million miles towards midnight. It's this sort of counterintuitive one where as you orbit the Sun just beyond the Earth, you can actually stay hovering over the Earth because you're trying to orbit at a certain speed, but then the Earth just ahead of you drags you on that little bit extra. And so you have this weird balance thing. And we use this for astronomy satellites a lot, particularly the amazing Gaia satellite, which is a European satellite mapping the galaxy, is out there at L2. But when we say at L2, it's actually orbits around this imaginary point in space. You can sort of treat it, even though it's an empty point, you can treat it as if it's something you can orbit. And the radius of that orbit is actually something like the radius of the moon around the Earth. It's an enormous thing. Okay. So the size of the L2 point is like 500,000 kilometers across, right?
So it's not something where we're going to run out of space tomorrow.
Right. And also, if you leave junk there, over a period of about a year, that junk is going to be perturbed by the gravity of the Sun and the moon into orbit around the Sun, or potentially, but less likely, back into Earth orbit. And so it won't stay there in the long term. So in order to stay there in this weird looping orbit around a visible point, the science satellites have to do a tiny little push of their thrusters every couple of months. So it's not fully stable, and so
that's quite nice, actually. It means you've got this resource which you can essentially use forever. You have your satellite that you want to live for 20 years, and then it will slowly.
Yeah, no, that's right. There's a whole host of reasons why L2 is a great place for a science satellite to be. Having said that, we are now as we see the inner solar system become this arena for not just the superpowers, but for countries, all different countries and private companies like SpaceX. We are starting to get. I have a catalog of over 1,000 objects that have gone out beyond the Earth, and it's no one's paid job to actually keep track of these. And it's not really a threat from the point of view of, you might bump into them. But it's annoying for asteroid discoverers who think they've discovered an asteroid and it turns out actually be some old rocket stage that just came back to the Earth after 20 years in solar orbit. And there are other reasons. You'd like to know the orbit of these discarded rocket stages because for planetary protection. So we don't want to contaminate Mars or the moons of Jupiter with biological materials before we've fully ruled out that there's anything there to be contaminated. And so what you do when you launch a Mars probe, right, is actually you aim deliberately a little bit away from Mars. And then once your probe is separated from the rocket, you correct the orbit of the probe to aim at Mars. And that way the rocket misses and just stays in orbit around the sun. And so it doesn't go too close to Mars, right? Where it might hit and contaminate, because the rocket is not sterilized.
I didn't realize
that. And so you spend a little extra money for a little extra fuel to deliberately miss and then re-aim the one bit that you actually want to get there. But the thing is, now you've got this rocket station orbit around the sun, and 20 orbits later, it could still hit Mars. And you're hoping that, all the bacteria on it have been sterilized by the UV from the sun by then, I guess. But still, it would be nice to know and not just lose track of them. And so I've been advocating that we need a NORAD, a space tracking, or at least space cataloging organization for deep space that we just don't have right now. Because until you know what's out there, you can't have really any governance, and you're going to need governance and coordination when you have all these different players out there. And
I suppose it's out of sight, out of mind. It's going to be very hard to convince people this is important until something goes wrong, right?
Yeah, that's usually the problem, right? It's any environmental problem only gets attention when it's almost too late.
So in terms of space junk generally, when did we realize this was a problem?
Well, let's see. The first real space debris event was in June of 1961. A rocket stage that launched some Navy satellites blew up and created about 300 pieces of debris, of which about half, again, are still in orbit. But really, people didn't worry too much about it until the late 70s. When we saw a whole bunch of these rocket stages blow up after 5 or 10 years after having been launched, right? And then people went, okay, we need to do something about this. And so what they did was design the next generation of rocket stages to be restartable so that they could do what's called a depletion burn after they delivered their satellites, and lower their orbits or re-enter entirely, and also, most importantly, use up whatever leftover fuel there was, so that they weren't ticking time bombs anymore. And that's making your rocket stage able to start in space, as opposed to during the launch phase, is actually a bit tricky, because you have this rocket stage floating in space, and it's like, it's got 10% of its fuel left, right? And that 10% of its fuel is floating in the middle of the fuel tank, not down where the exhaust is.
Okay, there's no gravity.
Yeah. And so you have to persuade the fuel to go to the bottom of the tank before you ignite the engine.
So you need some other mechanism in there that sucks it in.
An ullage motor that's a smaller maybe a little solid rocket motor or something that gives this whole stage just a little push to settle the propellants at the bottom of the tank before you ignite the main engine. So it's a whole thing, right?
But so is the space junk issue, is it more or less an engineering issue from the point of view that, if we designed our spaceships and our craft appropriately to take care of this issue, we shouldn't need to actively remove space junk from this point out, as long as we design mechanisms which account for what we're from now going to be shooting up into space.
Well, you've still got to remove the satellites and rockets themselves from orbit, right? Because especially in the quantities we're launching them in now. And so, yeah, if you require that every satellite and every rocket has the ability to remove itself from orbit at the end of the mission, instead of just leaving it there, you would mostly solve the problem, except for all the stuff that's up there already. And I think we are at a point now where there's so much stuff up there already that even without launching anything else, you're going to have collisions and you're going to have increase in debris. And so we really need the space garbage trucks. We need to remove the top 100 or so big pieces of junk in orbit just to reduce the collision probabilities.
So what happens if we do nothing? So worst case, let's imagine we just, put our fingers in our ears and completely ignore that this is a problem. What's worst case scenario, and what are the timescales that we're looking at?
Yeah. So the good news is that the timescales are decades. It's not like the movie Gravity, where there's a chain reaction in Earth orbit that runs to completion in about 10 minutes. But we're seeing this slow motion chain reaction. Essentially, we had the first collision. We're going to have another one, sometime, and so the end result is that you have a runaway, you have a chain reaction of things hitting other things, and reducing the orbital population to shrapnel, and making a Saturn's ring made of aluminum around the Earth, that would make it very difficult to use low Earth orbit.
Or even to gain, I guess astronauts have to fly through this as they're entering orbit, right?
Right, exactly. Yeah. And so, you'd have a shell around the Earth, and it's already becoming difficult to schedule launches in the gaps between the debris coming over.
Have they had collisions with launch vehicles during launch?
Not during launch. No, it's not that bad yet, but because they do take care to avoid that risk. It's more, it's annoying work to have to, run all the to schedule around them, I guess. So yeah, it's and there have been lots of minor collisions. You may have seen bullet holes in the space station where pieces of debris went through a solar panel, and so that happens. The bigger collisions that would just totally destroy a satellite and make lots more debris are still very rare. And so
what's my chance per year? So if I put up a satellite, what's the chance that gets taken out in any given year?
Depends on the orbit, but yeah, I would say, let's see, if there are 4,000 satellites and I'm guessing the collision rate is of order 1 per 10 years, 1 per 20 years, something like that, for a fatal collision, as opposed to just a damage collision. And so per year, that's 1 in 80,000 or something like that, right? For any particular satellite.
But then smaller collisions that don't actually kill the satellite, I'm guessing that happens more often.
That happens more often, and I would say, after 10 years in orbit, you probably will have had at least these minor collisions, right? And probably they won't have damaged you, but maybe they're degrading your insulation, or if you're unlucky, right, it went through a critical wire in your solar panel, and so I think it's a real problem. Certainly, in the ISS, which is a big target, it's soaking up, there are many little dings that it has.
Has there been any significant damage that they've actually had to go out and repair?
Not on ISS, no. I think they had an issue where they had, they had rough edges due to a collision on the airlock ring, and they had to sand it down or something like that. But
it's cutting up the spacesuit, the astronaut suits or something.
Right, exactly. Yeah. So that kind of worry, rather than, the solar panel is going to fall off or something like that. But there have been satellites that have been seriously damaged. There was a French military satellite who's had a gravity boom, which is like a stabilization thing, and it got sheared off by a piece of debris.
In terms of this, so the space station they move, right? Do they do that only with rockets, or can the station also shift around by changing its shape? Like how a cat would flip around. Do they do this or?
Yeah, so they have momentum wheels, and so you have spinning wheels, right? Around three of them around three different axes, and you can exchange angular momentum between the wheel and the station.
They actually, okay, I did not know that.
And that lets them turn the thing in some direction. That doesn't really help for avoiding debris because your cross section is about the same. But astronomy satellites use this for pointing at a new target. So I work on the Chandra X-ray Observatory. Excuse me. And we so when we've finished looking at one black hole, and now we want to move to look at this black hole on the other side of the sky, right? We exchange angular momentum between the spacecraft and its internal spinning wheels. And so we can do that without using up any rocket fuel.
But in terms of the ISS, that's not done for avoiding debris.
Not for avoiding space debris, because it doesn't change where the center of mass of the station is.
But the station's it's like a pancake, right? It's not.
Ish. I mean, it's got these huge solar panels at slightly different angles. It's got at a different axis. It's got the pressurized modules. And so it's not as pancakey as you'd like, in that sense. And usually the error bar on where the one of the problems, right, is that you can't predict. If I have a satellite and I know its orbit, I only know its orbit to a certain level of accuracy. And if I go, this is going close to the space station a day from now. My prediction on exactly where that satellite is going to be a day from now depends on a whole bunch of things that I don't know perfectly, including what the solar activity is going to be for the next 24 hours that will affect the density of the upper atmosphere, that will affect the drag, and so on. And so I have an error bar on where that satellite is going to be as it passes the space station that could put it on either side of the station, right? And so you're just as likely to move your station sort of into the path of it as you are out of the path of it. So
I see.
Yeah, better to move the whole, if you're worried, better to move the whole station by doing a rocket burn and raising its orbit by a couple hundred meters or something.
How often do they do that? Or have to do that?
They haven't done it lately. They've done it about 20 times in the history of the station.
I guess they're doing that anyway, just to keep lifting it up, so it's not a big deal.
Right, exactly. They do. It's a question of how much warning you get, because they do reboost burns every couple months.
And I guess when they do that, they calculate, okay, if we do the boost at this point, then we're going to be avoiding anything for the next years, let's say, that we know about this in orbit.
Yeah, I mean, you can't do it years in advance. So it's more that something risky comes along every few months, and you get maybe 4 days warning.
I see.
Right.
So what happens eventually? Okay, when's the end life of the ISS? When we want to bring that back down, what's the protocol? What?
Yeah. So the protocol is you dump it in the South Pacific, far from shipping lanes. And so what you do is you dock a cargo ship to the station. And lower its orbit enough so you fire in the direction of motion to slow its speed, and that lowers its perigee down lower, but not so low that the drag is so much that you lose the ability to control the station, right? And then you launch another cargo ship full to the gills of propellant, because one isn't enough to go all the way in one go. And now you fire that one to get it from where it was down to dropping the perigee into the atmosphere in the right place, right? And so you make sure that it re-enters at the right place at the right time. And they did this for Mir, the old Soviet space station, back in 2001. And so there's form for this. So it comes in, so it's basically you go from a 400 by 400 kilometer circular orbit to a maybe like 250 by 250 kilometer orbit to a 250 by 30 kilometer orbit, right? And once you're in that ellipse, so you fire the engines at the high point, right, to lower the perigee, to lower the opposite end of the orbit into the atmosphere. And so 45 minutes later, you come round to the other side of the Earth, and you're entering the atmosphere at 18,000 miles an hour.
So the error is pretty large on that, right?
Well, but it's not in the sense that you know exactly where it's going to enter, right? Or pretty much exactly. I mean, there's some error. There's 100 miles error in where it's going to hit, but not thousands of miles, right? Where because you're in this thing where it's trying to get to this low point at 30 at this particular place, and it can't do it because it hits the atmosphere. Whereas if you just leave it in a circular orbit and let the circular orbit shrink and shrink and shrink and shrink as it goes round, so that the drag, it's constantly fighting against the atmosphere instead of fighting it at one particular point of the orbit, then you have no idea at what point it's going to break up. And that's, for example, for that Chinese rocket stage that re-entered earlier this year. So we had no idea until after the event, to within many thousands of miles, where it would re-enter.
So what went wrong there? I'm guessing they lowered its orbit because they didn't want to create space junk, and this was the alternative that they decided upon.
Right. Well, the thing is, this was a 20-ton rocket stage, and normally we don't leave those in orbit. The standard way that everyone else uses is that you use that rocket stage to get almost to orbit, have little engines on your payload to go the last little bit, and that way the rocket stage is in one of these suborbital trajectories that then comes down and crashes in a predictable place.
But that was not done here? Or
that was not. The Chinese decided, we don't care. We're going to take the risk. We're going to leave this 20-ton rocket stage in orbit and have it fall out of the sky in some random place, because most of the Earth is ocean. So, we'll play the odds. This latest time they were lucky, it re-entered in the Maldives, but in the Indian Ocean, and didn't hit anyone. The previous time they launched it, they weren't so lucky, and pieces of metal hit villages in the Ivory Coast.
This seems pretty naughty. So what? But there's also been other cases. Was it Skylab that came down in Australia? So what happened there?
Right, exactly. So that was, again, we were talking about in the 70s, people starting to get pay attention to space debris, and that was one of the other seminal events. Was that Skylab did not have a propulsion system. The atmosphere, the idea was, when people started worrying about this, well, we'll build the space shuttle and we'll reboost its orbit with the space shuttle. And then two things happened. They didn't really properly take into account the solar cycle. That meant that in the late 1970s, the atmosphere was denser than it had been when they launched it. And so the rate of decay accelerated. Plus, the space shuttle was like 5 years late. And so Skylab re-entered uncontrolled, essentially. Large. It was a 70-ton object, and large pieces of it ended up in the Australian outback. You'll appreciate this. I remember the NASA TV coverage or the NASA live commentary where they went, okay, so it's passed over India, it's over the Indian Ocean now. It's now past the last inhabited area that it could hit. There's only Australia.
Thanks.
Exactly. I don't think you wanted to say that. That woke people up. And since then, that this idea that you don't leave big things in orbit to re-enter and control arose. And so since then, they started on the largest objects, like space stations, adding rocket engines to deorbit them at the end of their life. And over the 40 years since then, that sort of threshold of how big a thing do you worry about to make sure it doesn't re-enter uncontrolled has come down. So that now I think anything over 10 tons, unless you're Chinese, and anything over 10 tons, you try and make sure it doesn't re-enter uncontrolled.
This might, I mean, they're sort of fairly new to the game, right? This might be something that develops just in the years to come for the Chinese as well.
I think so. Yeah, I think they have been slow to adopt the norms of the rest of the space community, but they do it. And so similarly, the other big resource we have in space is the geostationary orbit, which is full of communication satellites. And it's a very sort of thin ring around the Earth. And so starting in the early 1980s, people realized, as it started to become popular, we don't want to have lots of dead satellites in the geo ring. And so it became a norm that you, at the end of your life, you leave a little bit of fuel to boost your satellite up out of the geostationary ring to what we call the geo graveyard.
Why do you boost it up rather than down?
It would take huge amounts of it. So geo is really high. It's 36,000 kilometers up. So you need enormous amounts of fuel to deorbit. It's just not practical. So
is there any conceivable case in which this space junk could be used in the future? Like, you just have orbits filled with aluminium and all sorts of. I guess that everything's moving too fast to make use of.
Well, except in the geograveyard, right? Everything is going around the same direction at equatorial orbit, and the speeds are not as high as they are in Leo because the gravity drops off as r squared, and so I wonder if the geograveyard could be used for salvage at some point. What's happening now is that there's Northrop Grumman has started a business where they will launch and use a little satellite to go up to your old geostationary satellite and dock with it before it becomes junk, but just before it becomes junk, to give it an extra 10 years life.
They inject fuel, or what do they do?
Well, no, they have the fuel so it's like a parasite satellite that locks onto you, and it provides the fuel and pointing to your existing communications payload.
I see.
Right, and so it's essentially a booster pack, that you strap onto your satellite, and
has that been done? They're doing that.
It's been done twice now.
I'd never heard of that either.
Yeah, just in the past couple of years. So that's a new business, and it's not clear how cost effective it is, because once your satellite's already 15 years old and you're doing this, do you really want to launch another satellite to use this old communications technology, or do you really want to just junk your old satellite and buy it? Like, do you really want your 15-year-old PC, right, to open it up and put a new power supply in, or do you want to send it to the knacker's yard and buy a shiny new PC with all the latest USB 3s and whatever connectors and stuff like that, right? In my case, right, I'm going to buy the new PC because it's just too painful trying to use stuff that's that old. And I think that's going to be the case for a lot of communication satellite companies. So I'm not super convinced that the market for this keep your satellite working another few years is big enough, but we'll see. Maybe I'm wrong.
On the commercial side, is the entry of we have these new constellations. So, for example, what's the one that SpaceX is running at the moment?
Starlink.
The Starlink. Is this in some sense a disaster from the point of view of space junk? I mean, because you have these huge or are they low enough that their orbits degrade quick, or it's a disaster? Is it?
I think so. Well, so yeah, SpaceX has been persuaded now to put all of their constellation in this lower Leo area, where if they die, they will re-enter on a 20-year timescale. But that timescale, right, is okay when you have 1,000 satellites in orbit. I don't think it's short enough when you have 30,000 or 100,000 satellites in orbit, right? So this is a real qualitative change in the amount of stuff in low Earth orbit. OneWeb, which is the other company that's already deploying its constellation, is up at 1,200 kilometers. And so that's even more of an issue. They say their satellites are more reliable and that they can bring them down at the end of their missions, but we'll see. And then Amazon is getting into the game. They're currently only planning 3,000 satellites, but they're Amazon, so they could easily invest more later. And China has a plan to launch 13,000 satellites. And so we're going from, we've already changed in the past 5 years in a state where most objects in low LEO were debris, and they still are in upper LEO, but in low LEO now, most objects are active satellites above 10 centimeters in the catalog. And so that's a real change in the environment. Most objects in the lower part of orbit are active satellites and not junk, and that's a change. And so, yes, they're active, so they can dodge each other if in a good day. Right.
Okay, so all the satellites in Starlink actually have the ability to shift they're not like these CubeSats, which are much smaller and don't have any.
And that's a problem. There are lots and lots of CubeSats that can't change their orbit and can't dodge. Starlink in principle can dodge if it has good enough information.
And if it hasn't been hit by something else.
And if it hasn't
that killed it.
Yeah, exactly. And so, they do all the math to say, we can maintain this constellation safely. But I, as a physicist, right, training, I worry about the non-Gaussian tail of the error distribution, right? The systematic errors and things like that.
When you're putting more and more and more up there.
Yeah, right. You start to get to the point where two unlikely things that are non-statistical things, right, are more likely to happen.
Is this sort of like sorry for interrupting, is this sort of like a tragedy of the commons sort of situation? I mean, no one really owns space, and so you put your satellite up and you think about what you need to do with no sort of thought to what happens 10 years down the track, 20 years down the track. Do we need to have the real estate that is sold out to groups? Or
yeah, I think so. I think we're starting to get to the point now where low Earth orbit certainly is a finite resource. We already do this for the geostationary orbit for communication satellites, in that the International Telecommunications Union coordinates longitudes around the Earth where certain countries can put satellites. And it's controversial. In low Earth orbit, we're going to have height ranges that get doled out, I think. And that is not in place yet, but it's going to have to come. And so, yeah, it's a problem. Up until now, low Earth orbit's been a free-for-all. Every country's satellites going in every which direction past each other. And it's sort of like a bit, it's not like a freeway where everyone has lanes, right? Motorway it's not the autobahn. It's like a big open space where everyone's going at hundreds of miles an hour in different directions and just dodging one another now and again. It's crazy, and it can't go on indefinitely. It doesn't scale another couple of factors of 10, I think. And so, at the moment, there is regulation by individual countries, licensing agencies. If you want to launch a satellite, you have to do it under the aegis of what, in the United Nations terms, a launching state, right? So you have to be licensed by a country, and then the country is liable, right?
Oh, I see.
If I'm Elon and I put up a satellite and my satellite hits a Chinese satellite, SpaceX isn't liable. The United States is liable.
Okay, so
and therefore, if I'm the FCC and I'm going to give you a license to say yes, you can launch your satellite, in theory, I should do my due diligence to make sure that I, as the United States, am willing to take on the responsibility that of you having this satellite in orbit. And so that's the theory of why things should be okay because, if you try and do something too dangerous, you won't get your launch license. And that works in a world where the government regulators are not really owned by the corporations.
Mm-hmm. But it sounds like you're not too confident that things are going to be working out quite this way.
Yeah, I mean, because, certainly in most Western countries, and indeed, to some extent in China, it goes a bit the other way, but the separation between the commercial enterprises and the regulators is not what one might want.
I guess there's a precedence, right? When the Soviet satellite hit Canada, there was a payout. In terms of the Skylab incident, did Australia get a payout from the States?
No. I think there was one place, I think, which just some school or something that had something land in its yard that kind of demanded compensation publicly, and there was a whip round by some American space enthusiasts to send them a few $100 or something. There was something cute like that, but no, in a formal way, there was no compensation. In general, there's not a lot of, because the Canada-Russia thing was sort of settled out of court,
mm-hmm.
right? There's not a lot of legal precedent for really implementing this liability convention. But yeah, I mean, and so yeah, that's an issue. So I think a lot of these things, it's just like, we were talking about, 50 years into the space age, right? As we get into this new era where just things are just so much busier and so much more is going on, a lot of things that were let slide until now are going to have to be formalized. It's like the boundary of space thing, right? Where, because there wasn't a lot of activity in this liminal area between air and space before, you were either well below or well above. It wasn't so important to say where space starts. Now there's a lot more activity, both military and tourist, at this 80 to 100 kilometer level, and so it becomes more important.
It sounds like you're optimistic then that this is something that's going to be a little bit like the hole in the ozone layer. It's something that we're going to, as incidents pick up and it starts to become, financially a problem when your satellite's getting hit by junk and so on. It sounds like you might be optimistic about us.
I think optimistic is too strong a word. I think there's a path to get out of this. That whether it will happen or not, it remains to be seen. But I think that we will, it will follow this usual environmental trajectory, which is things will get really bad. Finally, it gets to the point where it's really impacting the corporation's bottom line. And then they will scramble to do something. And it will be a bit too little too late. But maybe there's a path to thread that just enough, just in time. So yeah, I don't know what will happen. I don't know how bad it will get before people, there's a lot of, like, for the active debris removal, right now, NASA and a lot of the other US government agencies take the view that, the big problem is that these Russian rocket stages, and you'd have to get legal permission from the Russians to go and take them out of orbit if you wanted to clean them up, and there's no way that would happen, I mean, that's just pathetic in my opinion. I think that, the Russians can't be oblivious to this, and maybe if you do it as a joint venture, you can make something happen. So I think at the management level, there's still a lot of this is too complicated. It would be actual work, so we don't want to deal with it. And I think then it's going to have to get a bit worse before that mindset changes to, crap, we're really in trouble. We need to fix this now.
I think maybe a good way to wrap up this discussion is sort of, could you give some part, if you were given, if I gave you the magic wand where you're in control, what's your path forward to solving this issue? If you were given the crown.
Yeah, I would say set up initially a bilateral or trilateral agency, perhaps coming out of what's called the Interagency Debris Commission, which is a technocratic joint venture between the various space agencies, to do demonstration projects for active debris removal, and with an American satellite, an American garbage truck taking an Indian satellite out of orbit, for example, or something like that, just to get the international legal stuff established, and then try and bring the Russians in, try and bring the Chinese in, and try and have some sort of international agency that levies, that does some licensing for orbits and launches, and levies a tax on orbits and launches that can be used to fund the active debris removal. There's a bit of an issue here in that, as in many environmental problems, it's that means that the new players are paying maybe more than their share of the cleanup for the Cold Warrior mess that was made in the 60s and 70s. And so there's going to be some objection to that. But I think it's the most practical way forward.
I guess on the other side, just practically new stuff that goes up, you don't shoot that lens cap into space anymore. You don't.
Right, exactly. And that, there have been evolving norms to do that. And that's, used to be explosive bolts are cheaper than a hinge. So you use the explosive bolts. Now people put these things on hinges. So that evolution has been happening. And I think maybe formalizing that, or, but you have to look at what are the biggest impacts. I think the biggest impacts are the largest objects that are left in orbit uncontrolled. So you want to just really focus on that for a bit and try and clean that up. And as well as better transparency. We haven't got into the whole stuff about how how satellites get registered with the UN, how many satellites now are in orbit where we don't know. We know that these three satellites are these three objects we're tracking, but we don't know which is which, because they're all dead. and they never phoned home. And so, there's all kinds of regulatory stuff that needs to be upgraded for the 21st century and be on a more international basis. So an international space traffic control, I think, is part of what we need, because we have, right now, pretty much the whole world depends on the US Space Force for knowing where the debris is. So if you launch a satellite, you know where your own satellite is because it's phoning home. But if you want to know where another satellite is, you go to the Space Force and use their tracking. Even if you're in China, probably, for the most part, right? If you want to know where the Indian satellite is, there's no equivalent comprehensive service in China or Russia, as far as I know. And so maybe the thing to do is China needs to get its act together and have its own space tracking system that does this. And then the US Space Force tracking system is sort of at some level going to be moved to the US Commerce Department, which would make it easier for it to engage internationally. Right, because a lot of people might not want to engage with the U.S. military, and so that would then, eventually you might get an international coordination body that would do space tracking internationally. That instead of doing what they do now, which is to say, ESA, your satellite is so ESA and China. Your two satellites are going to pass within a mile of each other tomorrow at 3. One of you might want to move, right? That's where things are right now. We would have a more space traffic control thing where instead of saying that, they would say, ESA move down 1 mile, China move up 1 mile, right? Rather than leaving it to emails between the ESA and China operators to decide who's going to
figure it out,
who's going to blink, right? And so I think that's we've got to go to something like that in the long term if we want to sustain the level of traffic that we have now, never mind the level that's envisaged.
And if you could enact a scheme, am I allowed to shoot my Tesla Roadster into space, or are there limits on that as well?
I think you have to be open to all kinds of uses of space, and so I think you manage the resource in a way that you can shoot your Tesla Roadster into orbit around the sun, which is what Elon did. And just so everyone knows, it's still bolted to the rocket stage. It's not floating around on the car. They've angled the cameras, so you didn't notice that. But that thing, it's in orbit. Tell me what its orbit is, right? And make that officially, in an official place, so that people know how to avoid it. And if you're going to put it in Earth orbit, is it within the quota of that orbit for this year?
Mm-hmm.
Right? Get in the queue, I guess it's going to be.
I have to, while I have you here, I have to ask you some non-junk related questions if I'm able.
Sure.
So, quick question. You're given the opportunity, one-way ticket to Mars. Do you take it or not?
One-way ticket. I mean, depends what's on the other end, right? Is it Mars as it is today, or Musk City is there waiting?
Musk City.
Yeah. I think today, no, but 10 years from now, as I'm getting older and I'm gonna die anyway. Maybe I could see that, retire on Mars. I mean, it's gonna be grim. It's going to be, even in Musk City, it's a very frontier lifestyle, right? And maybe there's all kinds of issues about to what extent are you Musk's slave if you go there, right? Is he absolute monarch of the city, or how do you govern it? Some really interesting work by a British academic called Charles Cockle about what he calls freedom engineering. How can you design into your Mars city decentralization so that the man can't rule everything?
Mm-hmm.
Right? Don't put your oxygen generation in one central place where the king can control it. Things like that, right? And so I think it's going to be. I mean, seriously, I do believe that there will be appealing settlements on Mars 500 years from now. I don't think there will. I think in my lifetime, if there's a settlement on Mars, it's going to need someone a little hardier than I am.
It's going to be pretty rough.
It's going to be pretty rough, yeah.
And do you think the first? So, do you think the Musk's Mars Direct plan is the way you'd go, or do you think Gateway, as NASA proposes, is the way to go in order to start settling and setting down a colony?
It's not clear that the Gateway is that helpful. I do think there have been some interesting ideas in coming out of places like Boeing, surprisingly, in for years, which you think of as a fairly staid company, but they had this nice idea of assemble your Mars ship basically at L2 on the edge of the Earth's gravity well, so that then it just needs a little push to send it to Mars, and so I think compared to 20 years ago, people being a lot more innovative about ways you might go ahead and do this. It's still, the biggest challenge, I think, is still landing very large objects on Mars, and which is a hard thing to do. It's easier to land objects on a planet with no air, use rockets, or on a planet with lots of air like the Earth, where you can cushion your fall. But just a little bit of atmosphere is kind of like the worst case. And so I think, it's going to take a while before the technology is really there. I will see how Starship goes. I wish Elon luck with that. But yeah, I don't really know what the successful approach is going to be. I think the exciting thing is that there are, I think we're beyond the era of a space program where we have a project that is going to go to Mars. Space is a place where many people are active. They're going to try different approaches, and I think we'll see. I think we'll see several tried, and some will fail, and maybe one will succeed.
Do you think there's a financial angle you could play for colonizing Mars? Is there some product that you can see that's obviously there that will make this viable?
Absolutely not. Not in the short term. I mean, and I think the settling Mars, I'm trying to avoid colonizing, but is having a human community on Mars. In the long run, right, if you want it to be sustainable, yeah, it's got to have economic production and trade with Earth. And it doesn't necessarily have to be things that you absolutely can't make on Earth. You can imagine, especially if it's information economy, right? You can imagine software companies based on Mars making money because they're transporting the software from Mars to Earth is cheap, right? And so I think but I think it's like a couple hundred years of investment before. I mean, one of the things, right, in the long run is it's pointless unless in the long run the community is entirely self-sustaining. Doesn't mean there's no trade, but it means that the point of doing this is that if Earth goes away, the community can still survive on Mars and you still have humans, right? And so for that, you need to replicate our entire economy, our entire industrial base. So it's not enough to grow potatoes, right? You have to grow semiconductor fab factories, right? And that's not so how you do that, essentially what you have to do is to make our entire civilization portable, which I think is a fascinating idea. And a worthwhile project, because that will have benefits back on Earth in terms of making our civilization more robust against local disasters and things like that. And so I'm fascinated by that. But I think the space settlement fans really underestimate what's involved in doing that. In having a really self-sufficient civilization on another world, and so particularly a world that, as Shannon Sterone has pointed out famously recently, is a really hostile place, and
that wants to kill you, more or less.
Wants to kill you, yeah. And so I mean, so does Earth at some level, but yeah, it's much more hostile than Earth, and so. Sterone sees that as a reason not to go. I see it as a reason to just brace yourself for the fact that it's going to be centuries before you succeed. In terms of, it's a tough problem, but it's an interesting problem, and so it's going to require more than one billionaire, I think.
If there's if intellectual capital becomes the thing that you sell, maybe that's what that's essentially what you're saying, right? That you're going to be selling software or ideas that are generated.
Yeah, I mean, maybe what else? I mean, there may be things on Mars that maybe the low gravity will let you make products that you're of interest on Earth. I think it's more likely that freefall, that space habitats will make products that are hard to make on Earth, but yeah, so it's not clear yet what that era will find valuable and will be cheap enough to transport back to Earth, right? But it's got to be, whatever you make, it's got to be very low mass.
My last unrelated question is to do with, so you've mentioned China's program a number of times. Some of the stuff that they're doing is actually pretty amazing, that they're able to do it in the short period of time that they've gone essentially from not having a space program to putting rovers on Mars sort of first attempt, which is really impressive. What's the significance, do you think, of China entering the game and sort of their accomplishments? How should we view what they're doing and where they're headed?
Yeah, no, I think it's hugely important. I think that China was like not so interested in space until the early 90s, and then they made a strategic decision to like invest and catch up. And so for the past 20 years, they've been just investing like gangbusters and really, going through every step along the way to replicate what the superpowers had done in the Cold War. And now they've caught up more or less, and now they're able to they are now a first-rank player. And I think that hasn't really sunk into some of the other space agencies because they're so used to thinking of China as behind. But no, they're a first-rank player along with the US, Europe, and Russia. With India and Japan, by the way, in the second rank, but coming up close behind. And the other thing about the very impressive, these government Chinese programs are very impressive. What's happened just in the last few years is that there is finally a true commercial Chinese space sector that didn't really exist before. Before, you had companies that were nominally commercial, but all of their board of directors was the Politburo or something, right? It was they were fig leaves, but now you have real commercial startups in China doing space, and so this commercial revolution in space that we've been talking about is not just a US European one; it's a Chinese one as well, and I think that's hugely significant for the years to come.
Escaped Sapiens.